Okay, this is a continuation. This is part 3 of the slides of my lecture, on project finance modeling. And in this lecture, now what I did is, I called it project finance modeling. They made me change it. So what? I put my little logo down there that I just made up. Okay, and I changed some of the original slides. I want to make sure that everybody knows that all you need is lookup, never ever V or H lookup. Sum if and index, and edate and maximum, max and min, and that's all you need. Okay, and then we have some examples. I'm not showing you this. This video is about refinancing and the dramatic effects of refinancing, which I glossed over in the last one. And it's also about interest rates and how important the credit spreads are, and what you can do about deriving the implied probability of default and how important that is. Before I say that, I made some extra little timelines. I don't know which timeline you like better, this one with the documents you have to do, or this one with my kind of father of the bride making a commitment and the commitment fee and all that. All right, and then I also decided the arrows really on this stuff, the arrows should always represent money. Okay, and if you're doing any kind of risk analysis, you should figure out who's giving the money. So shareholders give money and want it back, loan give money and want it back, EPC take money to do the project, O&M take money, suppliers take money, and then the big deal is the off-taker gives the money, and you got to understand this. And one of the things I didn't emphasize enough is, by definition, projects are big. And by definition, projects increase supply of something, whether it's toll roads, whether it's tunnels, whether it's petrochemical plants, oil fields. They increase the supply. When the supply is increased, there's a danger of excess supply. Enough of that. Okay, I'm just kind of reviewing. So we went through all this risk analysis stuff. And what we're going to go through today, or whatever, on this video, is a lot of how project finance is kind of represented by triple B. Whether that's exactly true or not is a different story. And then our case studies. And then we went through and did our kind of debt sizing. And this is the big one. Perhaps I didn't emphasize enough. If you don't know that the debt at COD is, I can't do anything about that. The debt at COD is a PV of the debt service. That's such an important formula, okay, for so many things. And then we talked about all this development fees and ways to increase the cost of a project without really spending any money. Big deal. And then here's what really the big deal is now. The big deal is, this one said, well, if you increase the tenor and you increase the interest rates, well, they increase the IRR. This is equity IRR. They increase it a little bit. And then they increase it or decrease it as the interest rates are increasing it. But look at this. The effect of the tenor is so much more important. But this ignores refinancing. And then the same kind of thing. We have the debt to capital, the size of the debt versus the tenor of the debt. And you would think that the size of the debt is one heck of a lot more important than the tenor of the debt. But if you go 60%, that goes up to 17%, which is the same as not the same, but a 10-year debt gets you the same as a 60% debt at 90%. You see all this. And then it looks like the tenor of the debt is really, really important here, too. Just a two-way data table. We'll do that later on a different video. I've already done that 1,000 times, so enough. Okay, and then we talked about sculpting, and I did not talk about refinancing. I think I have the number of the section out of order a little bit here. Now, assume that the debt, I have to read it. Oh, I should never read a PowerPoint. How horrible. The debt is going to be from the capital, a debt to capital ratio for this kind of analysis. But when we refinance the debt, we know the cash flows. So the the lenders are going to say, we see your history. We're going to give you some money based on your DSCR, even though at the first we just gave it on your debt to capital. If you don't like that, sorry. We can change it anyway. And then we're going to make a whole bunch of different assumptions about refinancing and demonstrate that refinancing changes everything, and it makes all those things that I just looked at like the debt tenor is much less important. Well, it's a little tricky. I shouldn't go that far. And here's what refinancing is. It's kind of, you can increase the equity return through refinancing. You do not have to refinance. It's like an option to cancel, an option to get out of a relationship, an option to exit anything. That's any real option, is an option to get out of something 90% of the time. We have an option not to do it. We don't have to do it. And the option depends on with things we don't know. Of course it does. We don't know when we're going to refinance. We don't know any of the credit spreads that are going to happen. Okay. But then to ignore this option value would be absurd, which everybody does. And I'm going to try to show you how to put it in a structured way. Now, refinancing, the other final key point is refinancing has so much more value when the tenor is short. So here's what I did. In an assumptions page in a model, I said, well, let's put these. These are not in blue because they come from this kind of a table with a bunch of different scenarios. But let's say we can refinance in 3 years after the COD, 7 or 10 years after the COD, and then we put our dates of the refinancing in, and then we say our refinancing is going to be defined by some tail. We can make a longer tail or a shorter tail. If we make a really shorter tail, the refinancing is much bigger. If this tail is only 2, we'd have much bigger debt. It's like a bigger debt size. And then we can define the interest rate and the DSCR. And then what we do is we just take these and set up 3 different debt schedules. And in our debt schedules, we put a lot of true false, is when we're going to refinance, what the tenor of the refinancing is, what the DSCR and the NPV using the true false is. I'm going to do a whole nother video on this because I think it's so important, and I can't believe that I've never done it before. And then we have the opening balance, and look, we have repayment from the last time we refinanced. No, yes, so this one stops when you refinance the next one. And it gets drawn when we refinance the last one. So we put a draw and an end term, and then the closing balance is the opening balance minus plus whatever. And we have an interest rate. Not so complicated, but if you have some circular references from taxes and maybe a couple of other details like LC fees and all that, it can get a little bit hairy, because you could put down here, DSRA assumption, fees assumptions. You can, clutter your thing up with 1,000 different assumptions. And then, here, oh no. Okay, well, I've got this a little out of order. I think I'm going to have to change this. Where's my refinancing case? This shows you, okay, hey, just a minute. Well, I guess that's why I'm doing this, okay? This is the refinancing assumptions. I don't know what I did here with the titles. Okay, sorry about that. Refinancing scenarios. Now, I think I saw some model by some really big investment bank. I'm not going to tell you who I was because I'll get in big trouble. And the person who was so nice to me, they had such a bunch of crap. Oh my God. Circular references that were with the iteration button, no graphs of the debt service, no refinancing. Oh my gosh. So even very advanced people don't do this, but this is the key. You don't know an option. You don't know what's going to happen in the future. That doesn't mean you ignore the value of the option. You're supposed to be finance people. If somebody says you're not allowed to do refinancing, what a bunch of crap. It really gets me. It's such a big political issue. Okay? And I say this kind of table where we have different, if we have 100 years, we never refinance. Then we can refinance in year 3, 7, 10, in 3, just one refinancing, 2 refinancings, more refinancings. When we refinance, we can put different tails in. And when we put the refinancing in, we can put different DSCR assumptions in. And then we can put different interest rates. What should happen is the interest rate should go down. And this is a standard setup of a data table with a code number and an index function down here. Index, index, index function. You can use the choose, what the heck, who cares? Okay, and then, I think I hopefully put it in the right place. So if we have multiple refinancings, here was our case with no refinancing. And we had the big, see it says no refinance down there. And we had the big kind of effect of the tenor. Now we put in this refinancing in, and the tenor effect doesn't completely go away, but my gosh, look at it. This one is affected by some kind of, I shouldn't have shown you that one, but whatever. Default in the early year, I think. But it changes it totally dramatically. I guess that shows you have to be a little careful. So I put the project IR on the interest rate because we're trying to take advantage of that difference. And then refinancing kind of always increases it, but it increases it much more for the short tenor than the long tenor. And you should put this in. Okay? And we don't, we could get a little philosophical. You could say, look, if you're getting crappy refinancing in the first thing, the banks are thinking there's something wrong with your project, and you're not going to get a better refinancing in the next. But then you can say, no, it's just the country, and there are, once people see what's really happening, once they don't get lost like I get lost on Google all the time, once they're comfortable with a project and have some history, then they're going to say, okay, we'll do it. We'll do it for longer. We'll have a shorter tail. Now, if you refinance later on, that means you're getting dividends. If in your longer tenor, you're getting more dividends in the early years, then refinancing has somewhat less of an effect. See this? Now we kind of have more of an increase. So this one has I'm sorry. Yes, this is later refinancing. The refinancing occurs later. If, on the other hand, we get a shorter tail on the refinancing, then it's a little better. And now, let me skip that one. Sorry. Now let's look at the interest rates. Let's look at our interest rate scenario. Sorry for skipping that last one. Shouldn't do that. I'm so bad at PowerPoint. But if we have no refinance, we have this thing where the interest rate seems to not matter and the tenor seems to make a bigger difference than the interest rate. When we put refinancing in now, what happens is in each case there's a big increase in the IRR, even in a longer case or the shorter case. But here, the interest rate is what drives everything. And that's really what should be happening. This is so interesting to me. And I can't believe after all these years I've wasted my career not understanding how to look at refinancing. But then I read a bunch of other stuff and nobody gets it either. And it changes everything dramatically. It says what you should really look at is the interest rates. That's the thing that kills projects, is a really high interest rate. If you have a short refinancing, don't do that. And then if we say, what happens if we lower? Remember up here, I put all these scenarios in, and one of them is we said we lower the DSCR gradually. So as we become safer and safer, we allow a lower DSCR. And we also lower the interest rate, which it could be the credit spread. Don't worry about the stupid nominal interest rate. Assume you have an interest rate swap or something that covers the interest rate in the economy. I'm only talking about the credit spread. I hope that's clear. I hope it's not clear that this is some kind of risk of interest rates changing. It's risk of credit spreads changing. And you always have the option of not doing it. come on, don't think it's interest rates. I think there was an S&P report that made it seem like it's interest rates. That's like refinancing a person's home. That's not what we're talking about here. And then when you do that, then again, the difference between the tenor kind of goes away, not completely, but a lot. And then the effect of the debt to capital, we can't do this with interest, is really dramatic. And the way it increases the IRR, showing you that equity IRR in a real in an initial model is just a bunch of rubbish. It really is, because you can kind of get whatever number you want. Get your project built and get a project IRR that's higher than the cost of debt, and then start exercising the options. I don't know what to say. So again, somebody who says, oh, you're not allowed to consider refinancing, what a silly kind of, I don't care if you're the boss, you're an idiot. Sorry. Consider a whole bunch of refinancings, because it's an option that depends, it's like a volatility in options. And they dramatically change the implications of what's important in negotiating an agreement. Spend a little less time, perhaps, on thinking you're so great by getting a long-term financing, and spending a lot more time on figuring out how to get a low credit spread. Okay, and if you got a short tenor, do not assume that remainder of that, you've got a 10-year loan against a 50-year hydro plant. What a ridiculous kind of assumption is that? Okay, now, so let's go to the interest rates, which was related to this, because I tried to show you here that the interest rates now are really important. And now what we're doing is I'm sorry I'm going back and forth, but what the heck, I hope this doesn't affect your eyes or something like that. It won't. You're looking at Excel too much anyway. That's a lot worse on your eyes, I'm sure. Okay. And then we said, okay, there's debt sizing, debt funder, debt tenor, and refinancing. I should have put debt repayment type and refinancing. And now there's debt pricing and then debt protections. And I'm probably going to exhaust myself before I get to all the debt protections. But let's talk about the interest rates. So there's our sculpting formulas, our tricks on getting the project cost higher, our sculpting analysis, our balloon payments, and we're getting to the interest rates. Okay, so when I say IRR on equity, there's IRR on debt. Debt IRR is an inflow versus an outflow. The debt holders, lenders, give you some money. They get some fees back, a whole lot of fees back, commitment fees, upfront fees, agent fees, something else. Shoot, just a minute. Oh no, I gotta pause the video. Okay, it's a real pain to edit that stuff out. Oh, God. Now, so where were we? Interest fees. And we're going to talk about hedging. IRR is the fees plus the debt service versus the input, the draws. Credit spreads can include step-ups. And what should you do in thinking about step-ups on the loan agreements? And then the hedging and interest rate swaps. How should we really do that? I just touched on that. Credit spreads, I just want to say how important they are. You don't think they make a gigantic difference. They're really, really important. And they're driven by the probability of loss. And we have anybody is a fraud who says they could compute the probability of default on a 30-year financing, the probability that some country will default on a PPA agreement, or the probability that traffic will be low, or the probability of technical things happening. That is a fraud. Even probability of the oil price is a fraud. We cannot compute the probability of default, but what we can do, which is a whole lot more interesting, is we can back in to the implied probability of loss. So here are some interest rates. You can just pick that up. I put some kind of cost of capital stuff for some yield codes. Now here's the basic theory. I don't know. I picked this up from somebody else. The loss on a loan is the default probability multiplied by the loss given default multiplied by how much the loan is at the time. Okay, whatever. All right. That's why we, in the last, you can just take if you've lost, the debt service, it depends how you accumulate things. And then you can say the credit spread should cover the expected loss. Maybe it should cover other things too, risks. Maybe it should cover, administrative fees or something like that. But bonds don't have the administrative fees. And what you can do is take that formula, and it's not just CS equal PD times LGD. It's a little more complicated than that, because it depends on the risk-free rate and discounting and all that. So I worked out this formula. But if you're lazy, just use a goal seek. And here's how you do it. I just put in, here's a risk-free scenario. We take 1,000 at 1.5. In 1 year, we get 1,015. Our rate is this. Then if we have a risky scenario, we have two lines. One is no default here, and in this case I have a 11.32 chance of default. In this case we have default, and there's 11.32 chance. And when we default, we lose half of it. So that's how much, if you add these two up, that's the expected value. And you can back into the default that makes the expected value equal the same. Now you can say, well, that's no good because there's risks. We should have a higher value here because we have risks than here. Okay, maybe that's true. All right, now this is from Africa analysis or a term sheet, and they said, we're going to charge you 6%. So I said, in 1 year, a 6% credit spread has an implied probability of 11.2% if the loss given default. That's a goal seek. I don't think it's that hard. Maybe I've done other videos on it. Maybe I'll do it again. But here's the theory. Here is the big, big deal. It's something called fairy tales. Maybe they scare adults too. They scare children. But compounding interest in IRRs is very funny, and it distorts things, and it has dramatic effects. So when you have a 5 or a 10 or 15-year tenor instead of this 1-year tenor, and I'm going to assume a zero coupon bond, so you kind of don't get anything until the end. That's just a theoretical thing. We'll change that later. Okay. So if I use the goal seek to compute a 6% credit spread, 5 years it has a 50.55% implied probability of default. I take this through people in Africa all the time. 10 years it has an 88%. 15 years it's more than 100%, which it can't really be. That means you have a higher loss given default. But as you go higher and higher, this compounding of the credit spread makes the probabilities of default extremely high. It's a simple mathematics. It's not complicated. It takes about 5 minutes to construct this sort of thing. Of course, I'm going to put this somewhere on the website and try to emphasize it and try to make it clear to you. And then we can say, well, what's the real probability of default? And they have this thing that, here's the default probability, here's 1%, so here's project finance and corporate finance. In that chapter 2, I think I gave people the wrong link for chapter 2. Oops, this is project finance term sheet, so that's pretty good if you can get that. In chapter 2, I have all this stuff on credit analysis. And in the credit analysis, I collect all this S&P and Moody's discussion of how they do it. And I compute these default studies. And I have S&P default studies. And these are kind of the normal ones where they go through all the crap that they do. I'm sorry, but that Lehman Brothers example, where they computed that as one one event. It's like some mom and pop shop had the same effect on their probability statistics for investment grade as the Lehman default. Enough of that. But here they have some trends in project finance. I wish they had a lot more of this. They obviously don't have much data really, because there's so much more project finances with loans than bonds. So let's get back. That's just showing you where you can get it and showing you why don't you get that Google Drive for free. You just have to email me, and I have not bothered anybody with advertising like for this thing or anything yet. Well, I promise I won't. I'm not going to be like these horrible people who pester you, guilt you into taking a class. How disgusting is that? I'm the one who teaches them. Okay, and then they have the loss given default, which they say the loss, this is really the recovery rate, isn't it? This is, where is this? The title, this shows you the recovery rate, 1 minus LGD. And it's almost always in this 100% bar. Now, it's kind of nice. They show you how their original ratings were kind of triple B, and then they fell to triple C. Except, of course, in Africa. Idiots. And then they show the default, time to default. That's pretty interesting. I don't know. What would be really interesting is not some simple thing. A good story on every single one of these. A story of what happened on every single one. How much? A whole lot of it looks like merchant power. Some was toll roads. There's Eurotunnel. Some was oil and gas. Some was nickel prices, I think. Okay. And then they have how they have the recovery rates in that thing, which is kind of interesting. And then look at this. Look at this. How horrible is this? Here is North America. 21% of the loans, I don't know, in volumes or numbers or whatever. 32% of the defaults. Guess who gets the lower credit spread? And then Africa, only 8%, but only 3% of the defaults. Latin America doesn't look so good. Europe looks better. What kind of crap is this? If you take this ratio for U.S. here, this is the 20 defaults divided by the portfolio. Look how much lower it is for Africa. I know that's not a great sample, but it just shows you how unfair life is. And then they give you something really, really interesting. It's a default rate on kind of loans, not bonds. But they don't give you the y-axis. Who knows? If this is, I don't know if this is 0.5%. I don't know if this is 1%. We don't know what this is. But they show you it's kind of stable. It didn't go up dramatically in 2008. I don't know what happened in 2002, if they included telecoms in here or what. Okay, now let's talk about the credit spreads and why this stuff is so unfair. We said triple B is kind of the bond level. Now, if you go to the disk, and I hope you look at this. Now, I worked on this. If you go to, you don't care about my travel reservations. Oh, come on. If you go to Chapter 1, I worked on this a lot, this databases and data retrieval. Nobody seems to care because you may all have Bloomberg or whatever, and I have this one called interest rates, and in this interest rates, I adjusted it. I put, the default probabilities in here from Standard & Poor's, but I also did a whole lot of work on it. Well, some work on it here. And I showed you how long it takes to download. This took 3 minutes to download all this stuff. And you just go to the St. Louis Fed and you collect the little code numbers and you put them in, and you can get all these credit spreads and all that stuff. And then you can get the different swap rates. They discontinued, the horrible people. And you can even get the implied inflation rates or something, okay? So this shows you the double B versus triple B and kind of how much higher the double B versus, look, it used to be so much higher. And then before the financial crisis, it got really squeezed. And, the double B here was kind of down here below 2%. The triple B was down around 1%. Now it seems to be more like 2%, and the triple B, double B, I don't know, it's swinging around a little bit. Here it got up to 5% or so, 6%, and then down to here right now. Oh, it looks a little bit 2.31%, and that's what I put here, 2.19. Okay, and then we can get more of the credit spreads, and then you can kind of pick your own. Okay, and show them here or not show them here, or okay, let's say. Excuse me, I want to show the double A spread too, so I add that in, okay, or take it out. That's you can do with the list boxes, and then we compile them all in a database and all that stuff. Enough. Okay, and then we use that. So we're going to compare these spreads to these default probabilities that are shown in that Standard and Poor's reports. Triple B is kind of down here somewhere. Ooh, I kind of did that badly. It's right here. All right. No, I'm sorry, that's triple B is right there. Triple B minus is right here. Just remember that. And this shows you by year how long the bond is outstanding from the time. Let's say it was rated triple B, and then it becomes a triple C, and then a D here. It defaults. And out of all those, about 10% defaulted by the time oh, shit, sorry. Oh, no, I never swear anymore. Okay. And then we go to this one. Now, here's what I did. I don't know how much you have to pay attention to this. I love doing this. I took a bond. I said, let's take 1,000 a bond, and let's make a credit spread, which is our base rate, which we just get from all this stuff. We go up here and get our credit spreads and put in, what rating it is, and then put in these default probabilities, and then let's see what kind of IRR we would have earned. And if we were a single B, and in this year or period, the credit spread was 6%. The base rate for a 15-year bond was 15, so our total rate was 8%. But then we would have some defaults, so our IRR, after we risk adjust it, and the way we risk adjust it is taking our total debt service that I made flat, and then you put in this default probability from the Standard & Poor's, and then you put a loss given default too. Where's the loss given default? That's what it is here. And then this is how much you generate if you lose money. If you don't default, you get the whole thing, but you have a lower probability of that, so your expected value is this one plus this one, and your IRR is 7% versus the 8%, but it's a whole heck of a lot better than the 2% you would have got on a base rate. Now, if you did a double A bond, so I just kind of have a little thing, then what changes is the default probability and the credit spread. And then your IRR is only 3%. After risk adjustment. So this, after risk adjustment, this seems like a really good deal. And I'm just trying to show you that these implied credit spreads, when you have these low ratings, like these things in Africa, gosh, it's so expensive. And here's a triple B one. You get 3.79 after you account for this default probability. And I think if we would have put a triple B minus, maybe it would have been worse. Maybe in that case, the credit spread here would not have compensated. Now, that's a pretty low credit spread. It might not have compensated for all this default probability. And that's the theory. That's it. Now I'm going to move to floating rate bonds. The only thing I want to really say about floating rate bonds is the idea that you should think about interest rates and inflation rates being so terribly tied together. I can't explain negative interest rates. Don't get me on that one. I'm sorry. But if you have a high inflation rate, people who live in high inflation rate countries know you have a high interest rate because you're going to lose your purchasing power if you don't invest. And you can even say that the reason the long-term rates are higher because we got inflation rate risk. Now, if you have anything, a PPA agreement where the capacity charge is indexed to the US dollar, you get inflation protection. Even in US. Because let's say the US, let's say you had some crazy thing where your country has no inflation, the US has a big inflation, then you get a devaluation. So enough of that. I'm just about to get. So here's how swap works. Enough. Now here's the problem with this fixing inflation rates when you have a fixed capacity charge or something that doesn't vary with inflation. If you look at the history here, just till 2017, we got a little. This is kind of an overnight LIBOR, and this is the 30-year swap rate. Huh. Every single time. This is not some minor difference. This is an order of magnitude. This could kill the IR if we could have got this interest rate. And then you say, oh my gosh, let's look all the way to 17 years ago. And every single time, the swap rate was higher than the floating rate. Well, we had some stuff going on here in around 2006 or 2007. So you could say, uh-oh, if we would have had a floating rate, I don't know, we would have installed a floating rate against our capacity charge here, and the floating rate went up, and I don't know. It's hard to get any scenario where the bank would have really been hurt that much from a floating rate. Of course, that can change in the future. Okay, so that's it. Now, and I put some stuff here, and I said, in the end of the day, you take that little file, I hope I have it open, and you want to see this interest rate. You go to this thing called double series chart, and you say, I want to see about what I should pay if I have a triple B credit spread, and I have, let's say, a 10-year treasury. And then you make it an area graph, and you can kind of see, well, the total interest rate, if you lock it in for 10 years, should be somewhere about, what is this, 2 and whatever, that addition should have added 2 and 1 is 3, about 4%. Now, if you could get, instead of this, a 5-year, they didn't put the swap rate in now, then you could get something lower, and if you could go all the way to floating, let's say 1 year, then they didn't show it back here, you could put a 1-year swap rate, I think, but then they don't have the current level really. So I'm using a 1-year treasury bill, 1.2 plus, so you could get 2.459 or something as your interest rate. That's what you're supposed to use this stuff for. So I was promising originally when I made this whole thing, I was going to, I'm not finished. Oh, no, I'm not finished. I got one more thing to do. And what are we on? 38 minutes. I'm not going to make you keep going here. Let's stop here. Here's the one last thing I want to talk about. And that's I better not show this thing here. I want to talk about stepped up credit spreads. When you step up credit spreads, what's the theory? Some people say, the theory is that longer term we have more risk. What a lot. No, it's not. Here's the thing. When you look at these deals with step up, and this is not a dramatic step up, the one I have now. And then look at this. This is kind of cool. They have a 15-year balloon payment in this one. All right. When you have a stepped up credit spread like this, what the bank is telling you to do is go and refinance. That's what they're telling you to do. And basically what they're telling you to do, if you have such a crap project that you can't refinance, at least I'll get a higher interest rate. It's kind of a little interesting protection. Now, if you make a base case scenario, how could you put in these stepped up credit spreads. It's totally inconsistent. And I know you're going to have somebody who says, no, that's the rule, that's the rule, that's the rule. You take your term sheet or your loan agreement and you have that, right next to your computer, and then you just are taking one agreement, and basically what you're doing is modeling all these agreements, and that's what I have even said you're really doing. But in this case, the refinancing, like I said, changes everything. You need to look at what you think the market would be for a base case, and I know you don't know it exactly, so what? That's the most irrelevant thing, because, especially with a higher stepped up, they're forcing you to refinance. So you're going to have to put different credit spreads in a base case than a downside case. Enough. Okay, enough of this. I'm going to stop now. Get myself all worked up. Okay, goodbye.